Cool. Check it out, guys. That little ding dong that you just heard means that I finally have a working chat app, right? Sorry to nudge the microphone. It's slightly difficult to adjust the camera now that the stand is in the way. Let me just check how focused the camera is, and I'll tell you what, I will refocus it the way that I said I would. I did last time. So yeah, sorry I'm doing this right now. Get a good view of the Connect stand in the wrong orientation. Just because because I only just remembered to do it for the first time yesterday. Uh, I forgot that I can just do that. So I forgot to do it before stream. That's my point. Let me just. It doesn't seem to have helped much. I guess it's a bit low lit, but never mind. Yes, so finally I installed Chatty, the chat app, meaning that I will get a ding dong anytime somebody writes a chat message. So a problem that should have been solved a while ago is now solved. So here is the progress. God, yeah, stress level slightly higher than usual. Probably, I kind of sunk into just listening to music for like an hour, and so didn't leave myself quite enough time to prepare for the stream. I was in kind of a rush at the end, just sort of washed my hair quickly, put the hat on again so I don't get a cold. But you know, with experience comes a kind of calmness that you know what you're doing, even though I'm slightly more agitated than usual. You know, this is the 9th stream that I've done. Fairly comfortable, you know, that I know what's going on. It says it's live, I can see everything, I can see the mic level, and so I can be confident that everything's going fine. And I can just get on with what I was supposed to be getting on with, which is... I just got an alert that I started streaming for whatever reason, a couple of minutes late. Which is, I am jumping in back on the Raft project with part 2A. If you remember what we were doing, well, this is what we're doing, part 2A. And I made myself a couple of scrap notes that outline how Raft works. Actually, what I am going to do... Sorry, eyes are a bit stressed. What I am going to do this time is something I had the idea to do earlier, but I wanted to do it on stream. Just tidy the scrap up. And by tidy, I literally just mean make an old folder and chuck everything that I'm not using into it, using Control Space to select stuff, so that I'm just stuck with Raft Index and Raft Interface, the two useful text documents that we made last time. If you recall, that kind of outline in a general sense how what we think we understood from last time. Not that we think we understood much, because obviously I haven't actually started yet. But I mean, as far as the section goes, this is the first section of my second stream on Raft, and it is do part 2A. Here it is, start doing part 2A. So I'm going to jump straight in with experimenting with sketching the code while I read it. So I'm going to try to not read and then sketch, but instead just do the sketch, jump straight on. Try to process the information, and then when I'm happy, go to implement, go to debug, all the fun stuff. And you know, there is a lot of stuff to do, I guess. So this is where the projects start getting a bit harder. I have this stuff that doesn't really make a lot of sense yet, that I'll probably just very quickly go through just before I start, and then I will you know, read the task so that we know what we're doing in general, and then probably read all the hints. Testing is fine. When we get to that, we'll get to that. That'll be after the implementation, but just reading the task and the hints, and then trying to sketch all of that out. Okay, so very simple. Just to calm myself down, I will just give myself a minute to breathe a bit, prepare myself for the ordeal that is upcoming. Next sesh is going to be straight after this one, so 12 to 2 p.m. tomorrow, which is... Tomorrow is Saturday, and Sunday comes afterwards. Afterwards, I don't want the weekend to end. It's Friday, gotta get down on Friday. Everybody's looking forward to the weekend. Yeah, a dubstep remix of that popped off back in the day. It just kind of fit, just putting the simple kicks in there. And then, the wobble, obviously, just for the comedy. Oh, and also the Bob Dylan remix of Friday, which sounds more like Lou Reed, just going like, fan, 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 fan. Lou Reed remix of Friday. Popped off back in the day. That was 2011, that's 7 years ago. Around about this time of the year as well. So, yeah, sick. Don't know why I started talking about that. It's a good way to chill, I guess, just take your mind off stuff. Do a bit of breathing, a bit of meditation. Actually, I'll do that, why not? I'll just do like half a minute of deep breaths and calmness, even if I'm on stream. Man, don't care. Just relaxing. We have a bit of oxygen coming in from outside, of course. Yeah, I don't know. Maybe I was going a bit too fast and then I just ran out of breath. Maybe it accumulated. But certainly a bit of time to chill just before the stream is always good, because I was in too much of a rush. I get into such a rush that I don't even want to like do the synchronization tests and all that just ahead of time. But as it is, I'm feeling okay. I'm just gonna start. So yeah, not the most productive 8 minutes 20 that we started with there, but such is life. Always good to take a break. 10-minute break, 5-minute break every 5 minutes. That's the way we did things in Mr. Wes's mechanics lessons back in day. He was a new teacher, so we just pulled the wool over his eyes mercilessly, which was unfortunate. But he was backed by the head of maths, who was just got incredibly angry when we did this, and he had so much experience. We just couldn't do this shit. Couldn't get ourselves let out of lessons early, and that, which is probably, well, I wouldn't even say for the best, because A-level maths is obviously for someone in the position of doing STEM at Oxford, Cambridge, A-level maths is fairly negligible. So any time we could have been let out would have been fine. Let out early, I mean. But like, that just sets such a bad precedent. It's just not on the level, so it's fair enough that it didn't happen. Yeah, throat has been really sucky recently, unfortunately, but I will survive. Let me just quickly set the microphone to a slightly better angle. I literally just nudged it and it just fell down a bit. Don't know what that's about. Okay, never mind. That's enough. That's enough of the chit chat about nothing. Just the relaxing chit chat. You know what I'm saying. All right, check it. Let's get on with it. Raft interface. Yeah, it's just, I don't know, a lot of technical shit, isn't it? We said there were these three messages, sorry, these three functions that are kind of important, and apply message, which is encapsulates the idea of communication, I guess. Laptop's running pretty cool. I like it. I like that. So let's look at, starting from the top, make creates a new Raft server instance. Some server runs make, fuck knows which one, doesn't matter. It has a list of all the servers it's going to be using in the form of network identifiers, whatever that means. Technical detail doesn't matter, including itself, and that's supposed to conform to whatever standard LabRPC uses. LabRPC is the RPC library that MIT has specified, which is different from a regular one because they put in more warnings, and also they use Go channels instead of Unix sockets. So all that shit from the MapReduce project about Unix sockets not working on Windows, as if, just forgotten about. It's as if man never cared about any of that shit. So it's a shame that they didn't retroactively port this library into the MapReduce project, because then I probably wouldn't have had to go through 6 hours of installing Linux. The rant. But, it doesn't matter. Doesn't matter too much. All that is safe now. I'm running basically on Linux anyway, so it's all good. So yeah, it identifies the computers, the servers, it identifies itself in among the servers. Persister I just put later because it doesn't say anywhere what it's supposed to be, what that's supposed to be. I would say persistence is an idea. So this is the idea of if things crash, the state is recovered. So whatever it was in the middle of doing gets recovered, which wasn't a thing in MapReduce. If the worker crashed, it got rebooted and got assigned a new job because the master had control. The master persisted stuff. And if the master crashed, the entire thing was restarted. So persistence wasn't really a thing, if you see what I mean. But part 2C, this will be implemented. Then we'll probably learn what this is about. These are just, these are the arguments of the make function. I should just clarify that. Apply channel is a, what's the word? Fixed channel, as in it's already been defined in the background of this, so I can just type apply ch, leave it there. But the point is there is a channel that receives apply messages, which is a special message type specified here. It receives them and forwards them onto whatever service Raft is helping out. What do I mean? Whatever service is using Raft, that's what I mean. Raft. So the key value service from project 3, that's the example of the thing that's going to be using Raft. So that is what is receiving from apply channel, and what is sending to apply channel should be, it doesn't make a difference in the make function. That's just registers what the apply channel is. So like I said, it's just going to be the words apply ch, because that's already been defined in the background code. But what sends it is, I think, every peer sends an apply message to the service, i.e. to apply chan. Something sends apply message to the apply chan, i.e. every peer, as specified in make. So yeah, this has been written weirdly like this, purely because that's how MIT essentially specified it. So if I wanted to consolidate this information, I would say ergo, therefore, ergo, every peer sends an apply message to the service. Whoops. To apply chan, sorry. Which sends to the, which I'll just put like forwards to the service, I think. Because this is a deduction, I guessed. I was going to say modus ponens and that, putting these two together, these two lines, into this line. But, no, I mean, I don't know if it's right or not. I think this is what happens. I'm not completely clear. Say I'm 80% confident that this is what happens. Every peer sends an apply message to the apply channel, which forwards to the service. I think that's how it works. It just seems to make sense somehow. What can I say? Starts consensus on a new log entry. Don't forget, Raft is all about the peers contributing to the log, which is all the commands. They agree on the order in which commands are executed, and like the client that uses the service or Raft receives commands from the client, and depending on like which peer received it, it needs to be able to, I think, that it needs to then be able to synchronize putting it up, putting the command um, um, in the log, because the service will be reading commands from the log. Apply message, I think, is a command that has been written to the log and agreed upon by the peers. That gets sent via apply message, but because it's distributed, every peer is sending the same thing. It's a bit, I don't know, it's a bit unclear how it works exactly. We said there seem to be two kinds of consensus. One is all the peers agreeing what the command and the log should be, and the next is not consensus, sorry, two types of committing. So one is committing to the log once every peer has agreed what should be committed, what the next command is, and the other is committing to the service, and the peers are directly sending to the service, and the log isn't even really mentioned here. It says that once it's committed to the log, every peer sends it. So maybe that's just in case of redundancy, so it receives it from one of the peers. Not clear, doesn't matter. I'm just trying to talk my way through it. It will all be a lot clearer once we get on with it. Get state is just a thing that it's like start, but doesn't actually do anything. It just returns information. Start returns the same information, but it's not important. And this is just logging where there is example RPC code. This contains example RPC code. This doesn't. This is something I'm supposed to fill in myself, so I'm not sure why they mentioned it that way. But nonetheless, it stands to reason, as they say. This is going to be important as an example to copy from to fork for how to do RPC and ting. Okay, that's it. That's all that we have to say about this. So yeah, I guess what I will do is just register in the chat after 17 and a bit minutes that I'm gonna just start, just for a potential subdivision, that I'm gonna start reading 2A. Start reading 2A. So I'm about to start reading 2A. Let's go for it. Jump straight in now that I have a bit of... Yeah, it's interesting. It usually takes me a while to get into work, anywhere up to 10 minutes, as you just saw. Whether it's breathing, whether it's distraction, I don't know. But it's easy to continue. Once you've started, you just breeze on, keep the vibes going, because this is vibes and stuff, and we are kicking it. I barely remember that song, but it is a classic. Let me tell the time. I think that the thoughts near to be the now. I don't know any of the lyrics that I tried to remember a few of them, but I just couldn't. It's just like bits and pieces. Like when Q-Tip just starts listing women's names, for example, I'm not going to remember that. Never mind. Yeah, okay, fine. I will blow my nose briefly. I think having the window open might be what's giving me a cold. I should probably have put the sweatshirt on, but it's not actually that cold outside. So sorry. Let me just sneeze. I'm aware that I said I was just about to start this and then didn't. But such is improvised live streaming. Sometimes you just have to. Sometimes you just have to sneeze or actually blow your nose. Bloody hell, throat is really just ruined with like phlegm and that kind of thing. It's just, never mind. Check it. Okay, so yeah, we have our skeleton of how the Raft interface works. This is like mostly what the reason why it's labeled interface rather than general outline or whatever is because this is kind of from the perspective of the service that's using Raft, like the key. So remember what I mean by service is the thing that uses Raft as its consensus protocol. So the key value service, for example, that thing. Um, this is what Raft looks like from its perspective, more or less. These are the kinds of functions it's going to be calling. I guess, yeah, the service uses make to create the Raft server, and it does the start. Does it do the start? Maybe there's something else does the start. I'm not sure, but generally speaking, certainly when it comes to how apply message works, um, that very much, this line and this stuff, that very much fits the service eye view of what's going on. Cool. Notwithstanding, I'm gonna load up a new notepad document and put it up in the corner. It fit perfectly. And yeah, just sort of get on with it. See what we're doing with part 2A. Let's see if we can get an idea of what 2A is. Yeah. So I'm gonna be live. Just save it as 2A in the same folder as all the other notes. I'm gonna be live, trying to deconstruct the question, right, as we go, as we read. So very interactive kind of reading, yeah. Yeah, so as we said last time, the big 2 points, I'm going to plus them. Leader election, heartbeats, heart bears. So, I highlighted these because leader election and heartbeats, it just says the task is implement those 2 things. So those are the things we are aiming for now. Eye is closing, left eye is a bit closey today. Append entries RPCs with no log entries. Those are the heartbeats. Heartbeats equals append entry RPC. Let's call it an empty append entry RPC. So with no log entry. So the point is append entry clues in the name. It should be used for committing log entries. Yeah, okay, that's cool. Totally cool with that. Let's check the streaming is. I do sometimes check the streaming is working, just because there is so much dodgy hardware in my stack here that the OG microphone and the medium shit Android phone, Moto G3 with less than a gigabyte of RAM. Yeah, you'd best be checking that things are actually working properly. But the PC is actually keeping quite chill. Surprisingly, it's very quiet. The goal for part 2A is for a single leader to be elected. Elect a single leader. Oh, actually, yeah, let's just write down the leader assertions. Number 1, and let me just space it out a bit so that it's clear. Number 1, single leader is elected. Remains leader. For the leader to remain the leader if no failures. New leader takes over if old leader fails. In fact, new leader takes over if and only if, because if the new leader doesn't take over, the old leader remains the leader. So I can just delete this line. New leader takes over if and only if the old leader fails, or if packets, which are kind of like network data. 2 from old leader are lost. Don't know if that's necessarily the old leader's fault. If packets to and from it are lost, what if it's the other side that's at fault? Never mind. Sorry, the eye's really pissing me off. Yeah, definitely chill out a bit before starting the next stream. I tried to just sort of ride it out, run, go with it, but never mind. Yeah, so goal for part 2A is for a single leader to be elected, and it remains the leader if there are no failures, and the new leader takes over if the old leader fails, or if packets 2 from the old leader are lost. I've just rewritten it there, and we know what the test is. We know how the testing works. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 hints. I counted correctly even though I skimmed it last time. Fuck this. Look at this. So many hints. So many hints. Alright. So I'm gonna just I'm gonna fetch my jumper. It's just on the fucking piano keyboard over there. Let's see if I can reach it with like a big lunge from sitting. That'd be a bit far. Oh, fuck. Ow. Dear Lord, that hamstring stretch. And I actually lost my the original plastic box I was using to keep the laptop elevated, so that the exhaust fan, has a bit more air to use. But I found a new box, but now I just found the old one just now underneath this stupid hoodie. Oh, God, that stretched all my muscles more than I wished it would. But it's done. Oh, fuck, I think I wrecked my shoulder by doing that. Never mind. Soz. Is camera still fine? Yeah, camera's still fine, and I will probably get less of a cold this way, so it was worth. It was worth. What can I say? Winter. Lol. Add any state you need to the Raft struct in raft.go. You'll also need to define a struct to hold information about each log entry. Your code should follow figure 2 in the paper as closely as possible. Figure 2 in the paper, it's a picture, an actual picture, not a fucking illustration. Illustration, which is what the previous thing turned out to be. You have to move the microphone back. Sorry about the rumbly noise. I had to move it back a bit because it'll get in the way of my gesturing. Like if I smack the microphone, there'll just be a random big noise. Figure 2 is a genuine picture, so I'm gonna look it up. Where is the list of shit? Here. I think this is where figure 2 is. It's in the paper, isn't it? Yeah, this is the paper. In search of an understandable consensus, dear Lord. Shit's hard. Shit is hard. Look at this. Unfortunately, Paxos is quite difficult to understand, in spite of numerous attempts to make it more approachable. So we threw it out and tried to make a new one. Both builders and students, system builders and students, struggle with Paxos. After struggling ourselves, we set out to find a new algorithm. Sick. I'm glad Paxos was replaced, if that is actually the case. That means that this should be easier than 2015 MIT Distributed Systems course, potentially, I don't know. Maybe not, we'll see how it goes. Maybe they use the opportunity to make it harder now that it is more understandable. Don't forget, it says in the problem sheet that we're gonna have to go over Raft a number of times to make it understandable. So the first implementation is going to be terrible. Oh my god, it's going to be terrible. I just saw figure 2. What the hell? Look at how long this is. Yeah, no, nobody said it was easy. I don't know any other words in The Scientist, but there it is. It's a decent song. Dear Lord, what is this shit? I'm gonna save a copy of this picture, if I can. Well, it should be just part of a P. Oh, it's not actually a picture, even though they called it Figure 2. It's not a picture. It'd be nice if I guess I can PDF print a single page. I'm just gonna try to do that. There's a print button anywhere. Tools, print, print. Oh right, print. Okay. Microsoft prints a PDF. We're printing this page, which is called what for? Okay, let's do that. So then I can just open it up. Oh, it's not necessary. Sorry, clicking the wrong thing. It's not even necessary, I guess, to do this, but you know, why not? Just call it Figure 2 and save it in the DS scrap folder. You know, just alongside all the other shit that's already in that folder. Just add to the shit. Why not? Okay, I'll just open it now in a new instance. Okay, here we go. Check it. Looks good. A condensed summary of the Raft algorithm, excluding membership changes and log compaction, which are the two things, really the two things that are not being implemented in the project we're currently doing. If you remember, it said log compaction will need to be done for project 3. Cool. And membership changes also, it said, I think we don't need to care about those, if I recall correctly. So that's good. It summarizes everything else, supposedly. The server behavior in the upper left box is described as a set of rules that trigger independently and repeatedly. State. Yep, section numbers such as 5.2 indicate where they are. Yeah, things are discussed. Formal specification, more precise. Okay. Do we just read this? What do you think? I'm not convinced. I think I would rather persist with the hints that we have here. You know, will okay. Store. Laptop's warming up. State in Raft struct. You know, state variables will go in the Raft struct as it says here. Define new struct to hold log entry info, or if you like, info per log entry. So it's going to be associated to each log entry. It's going to be like an entry info struct or something. Sounds pretty good to me. Your code should follow Figure 2 in the paper as closely as possible. Yeah, we're going to need to read all that, definitely. Hopefully not anything other than Figure 2. That's just my naive hope. But we'll see how it goes. Fill in the request vote args and request vote reply structs. You know, so we already said we have one RPC-like thing that's already been defined. Here it is. Send request vote is already done for us. So we need to fill in request vote and the other one, which is like, what's it called? Request vote reply. Based on those two. Okay, gotta blow my nose again. Apologies. Let's pretend like nothing happened. As per. Modify make, the inbuilt make function, to create a background Go routine. You know, they could have just numbered this as a step-by-step guide, to be perfectly honest. Make. Add background. Modify make to create a background Go routine. Slightly I have to admit, I'm distracted by the fact that my eye isn't fully open. It's a bit clouded over the left one, and I have some water here. I just put my fingers in, I don't care. Hands should be fairly washed. Hopefully they are. Might get like dysentery or something if they're not, I don't know. Oh, that's actually helped somewhat. Just make it easier to read things without thinking, was I sure that I saw everything that was on the page? Which, yeah, I guess, I'm lucky. I've never in my life needed glasses. It is deteriorating vision, I think. But, it's like now you know how it feels. Can't be sure that you've seen everything. Not that you can ever really be sure, but you start feeling like, the words are not necessarily all there. Okay, back on it. So yeah, we're going to need to do request vote args and request vote reply. Well, why not? I'll just copy them in here. Do RPC structs. Request vote args and request vote reply. Right, make capitalized because I'm referring to the function. Add background go routine. That will kick off leader election periodically by sending out request vote RPCs. When it hasn't heard from another peer for a while. Leader election via by sending request votes RPC when it hasn't heard from another peer for a while. I think every peer is going to be running its own background go routine, and that background go routine kicks off a leader election which should involve all the peers. If it itself feels like it's been disconnected, that doesn't make sense. Because if it's disconnected, how can anything else receive its call for a new leader? Hopefully the paper will make things clearer. Hella, yeah. This shit is definitely, okay, it's too early to say definitely, but I would say it seems pretty hard to me just reading through it. MapReduce never at any point really seemed hard. It just kind of seemed a bit confusing what was what at first. This is a step up. Hopefully key value and sharding will actually be easier than this. Hopefully will, not necessarily, but see how it goes. I'm ready to take it on. Feeling it. When it hasn't heard from another peer. I think it means any other peer. Of course, it could also mean the leader. If it hasn't heard from a leader, elect a new leader. Seems legit. This way a peer... Okay, I should have just read this sentence before saying all that bollocks. This way a peer will learn who is the leader, if there is already a leader, or become the leader itself. Learns who is leader, thus, which is short for in this way, learns who is leader or sets itself as leader. Well, it actually just says or become the leader. So I'm not going to say sets itself, that is an assumption. It's just something, again, I think is true. Implement the request vote RPC handler. So that servers will vote for one another. There is a lot of stuff here, and I think it may be kind of in order, so it may be worth not trying to process all the information at the same time. So I will read slightly fast the next maybe 3 hints, and see which of them I should try to work on first. Implement the RPC handler so that servers will vote for one another. Yeah, so these are the structs and this is the func. Request votes. Handles RPCs. So that servers will vote for one another. This is, you know, I feel like I'm just building democracy. Like, why is this so complicated? Well, democracy is a fuckery, that's why. To implement heartbeats, define and append entries RPC struct, though you may not need all the arguments yet. Yeah, because at this stage we're not appending any entries. I think that's probably 2B. Instead, we are just having the leader send out heartbeats. Okay. Heartbeats. Leader sends out empty append entries RPCs periodically, and that has to be regular. Not well. I guess that's what periodic means. It's slightly ambiguous language, but yeah, this has to be regular because it's trying to make sure it's still in touch with something. So that's forever. Uh, writes handler. The handlers. Writes handler for this RPC that resets election timeout, so that other servers don't step forward as leaders when one has already been elected. Okay. Heartbeat timeout results in new leader election, leaders stepping forward, and if it does not time out, then no leader should step forward. No peer steps forward, servers, peers, whatever, steps forward as new leader. Okay. Make sure the election timeouts in different peers don't always fire at the same time, or else all peers will vote. What? Surrealism. Emergence. This is emergence. For me at least, because I have not a clue what's going on. Make sure the election timeouts in different peers don't always fire at the same time, or else all peers will vote only for themselves. And no one will become the leader. Okay, it does make sense that if everyone votes for himself, nobody becomes the leader. With you so far, but like what? Like why does that happen? Maybe I should not get so gassed about not immediately understanding something. I do have that problem sometimes in life. If I don't immediately understand something first time I read it. It's funny saying that, you know, being a math mo. But in maths, we used to just get so lost in those lectures that you just became completely apathetic and started feeling like there was no hope until you started trying to catch up and trawl through stuff, and then any progress was kind of good. So here, if I'm trying to, this is like me trying to stay on top of a maths lecture, and the point where I can't anymore, you know, I get like a sentence that I don't immediately understand, and then I'm like panic. But like I said, most maths lectures you stop understanding immediately, and you know, get wrecked. Uh, Trying to follow, and then you become apathetic, so the panic goes away. Silver lining. Um, yeah, struggle breathing, like I said, still blocks nose. You know, if the election timeouts always fire at the same time, the peers vote only for themselves and no one becomes the leaders. That is a weird one. I won't write that down yet because it seems like not a technicality but a subtlety. Um, whereas I'm just trying to get a hold of what basically happens. So I'm going to start reading the paper, the diagram in a sec. The tester requires that the leader send heartbeat RPCs no more than 10 times per second. There's a lot of RPCs, 10 times per second. So the tester says, no, that's too many. Probably like 2 per second is good enough, I don't know. Tester requires your Raft to elect a new leader within 5 seconds of the failure of the old leader. Ooh. If a majority of peers can still communicate, yeah, that's the non-halt, not halt, but pause condition. Halt in general English, but like temporary halt rather than computation theory style halt, which is forever. Remember, however, that leader election may require multiple rounds in the case of a split vote, which can happen if packets are lost or if candidates unluckily choose the same random back-off times. You must pick election timeouts and thus heartbeat intervals that are short enough that it's very likely that an election will complete in less than 5 seconds even if it requires multiple rounds. You know, yeah. God, the level of technicality is like, if you are puzzled about locking, there's going to be locking. Total fucking chaos, honestly. You know, and there's the whole you should check your code with the race detector thing. Make sure you use capital letters, that's fine. Print statements when a peer sends or receives a message, and collect it out by appending the this little piece of Linux information passing, essentially. Never. Well, I barely know any Linux, but at the same time, I don't exactly understand what the difference is between. I'll just type it here. This, and this, like message sending operators. Couldn't tell you which one does exactly. I don't know, but I know that this saves the file, so all good. I mean, I found that out during the MapReduce project. I didn't even know that. Before the project. I didn't even know that. So, what can I say? It is clear what the next step is. Read the fucking diagram. Here we go. Not here. Read the. This is part of why I made the new document. Did I close the new document? Yeah, I think I did. Just load it up again. Oh, apparently I didn't close it. Oh, it opened in Edge, Internet Explorer. I mean Edge. I mean Internet Explorer. I mean Edge. Internet Explorer in sheep's clothing, as they say. Do you remember Internet Explorer 6? That was a classic. It's a web browser that lasted like 4 years or something, a ridiculous amount of time before they finally managed to replace it. 4 years? Might even only have been 2, actually. I don't want to say that if it's not true. Let me just quickly check. I'm sure you can search the acronym and it will immediately find it. No. See, it was released immediately with XP, but then it was superseded by the 7th version, which was released years later. 5 years later. No wonder it caused such a catastrophe of stagnation in web technologies. 5 years on the same sort of not very good browser technology. But I mean, those were early days for the internet. Everything is so much more mature now when it comes to web technology. Everything it's quite amazing how much shit's improved. Imagine becoming a web dev in 2002. It's so different, so much worse. Lucky to be born when you are, in some senses, you know. Certainly to be this age and have such an active and productive music scene in London, that is incredible luck. Okay, quick check. We've hit 10 p.m. Check 10 p.m. Yeah, still, no, I don't know. If this does not really count as sketching. All I have done is rewritten stuff that was already written down. So this is still a read phase, as much as I would love it to be like a sketch phase. I still don't know what's going on. Trying to just hack my way, figure it out. Okay, let's figure out some stuff and see if we can read through all of this and understand what each element is. I think that's reasonable. I'm not gonna make notes this time. I think it's unnecessary. We'll quickly do another nose blow. Bear with, bear with, bear with. Honestly, I could not tell you why I'm finding it so hard to breathe today. Maybe the weather is changing again. Um, yeah. So I had the idea. Well, not the idea, just the thought passed through my mind that it's a very good thing that the next sesh is scheduled so close after this one. I sleep on it and immediately hit it tomorrow so that I don't forget any of this. So much stuff. Let's start. We start with the premise when looking at state. Well, okay, we start with the premise of what the servers are. Should we do you know what? I'm gonna do like a visual demonstration using notepads while I read this. I think that's a good idea. So servers. So we're gonna try to summarize what all the components are of Raft. The servers are an obvious one. In a network, the computers, the things that run the code. One leader, uh, one leader, and the rest are. Everything is a peer. Servers and peers mean the same thing, I would say, but like one leader, and the others are not identified. I think that I'm not going to type that out. Servers, one leader. Raft. Sketch. Sketch could mean anything in this context, but yeah. Okay. So, see, every time I blows my nose. Every time, fucking what? Every time I blow my nose, my eye starts closing because of all the like tearing up and stuff, and so I again struggle to read. But I should be okay. I'll tell you what. I'll make it very easy for myself. Just zoom the fuck in. State. The first thing we're looking at, the state that is maintained by the servers. We have a persistent state on servers, on every server. We have a persistent state on all servers. We have a volatile state on all servers, and we have a volatile state on the leader. Okay? Persistent and volatile. Persistent is the stuff that should in principle be recovered if that server fails. Although we're not implementing that until later. Nonetheless, conceptually, that's what the persistent stuff should be, I think. Updated on stable storage. Yep, stable storage file system, something that literally persists because it's like a hard drive or whatever. Um, Before responding to RPCs. Persistent state should be updated before responses to RPCs are sent. Okay, and this is the states. Okay, these are the persistent states. Current term, latest term server has seen. I do not know what the word term means still. I will have to check that. I've not found it defined anywhere. Latest term server has seen italicized. Sorry, fucking high. Or maybe it's just my concentration. Sorry. Latest term server has seen initialized to 0 on first boot, increases monotonically, of course. Don't know what a term increase is exactly. Well, maybe it will say later on. Voted for candidate ID. Candidate ID. Identifies a peer, I guess. Doesn't matter. That received vote in current term. The terms are maybe the rounds of voting. Term being a round of voting. I think that checks out. Or null if none. Log. Log entries. Each entry contains command for state machine. I guess I know what state machine means. I didn't last time I was speaking about it, but now that I think about it, reading through this, I think the state machine is the thing that executes commands in the sequence. And the log, command for state machine is the commands that the state machine will execute, the service running a state machine or is a state machine, however you prefer to see it, I guess. Whichever one of those is correct. Not everything is open to interpretation. So yeah, when it says log entries, the log of commands for the state machine in each entry, and term when the entry was received. The term when the entry was received by leader. The leader is important in some sense, not just for coordination, but maybe it has a privilege when it comes to determining what data should be written, what the log entry is, that kind of thing. What the latest happening is. Term when entry was received by leader. First index is 1. Yeah, that's just the indices, but term when entry was received by leader. Term is the voting term. Like I said, I think it's the voting term. Nothing to do with the entry when it arrives, but the term. I guess it's useful to keep track of what the leader thinks the term is. Okay, all servers have volatile state, which are just temporary state variables. Index of highest log entry known to be committed. Initialized to 0, increases monotonically. Commits index, where we are in the log. And last applied, index of highest log entry applied to state machine. Initialized to 0, increases monotonically. So we have that distinction that I was talking about commits. So one is committing just to the log, and the other one is what stuff. Don't forget, the stuff that gets sent to the state machine, i.e. the service, is the stuff that has already been agreed upon, committed to the log. It's already in the log. So commit index greater than last applied should be a reasonable assertion. Greater than or equal to, of course. But the distinction is definitely there between log entry known to be committed and log entry known to be applied to the state machine. So all these entries get first put in the log and then sent to the state machine, the service. So we have those are the two volatile state variables. Because if there is a crash, it can pull these variables off some of the other peers. But these are persistent. Why? I do not know. It just says it. I'll take it for granted for the time being until I understand it better. Volatile state on leaders, reinitialized after election. Yep, that just means cleared. And, well, you know what initialized means. Because it literally says what it is initialized to, so it just means set things to their defaults. Next index. For each server, index of, per server, other than itself, maybe even itself, index of the next log entry to send to that server. Why would you be sending log entries to servers, I wonder? Because everyone needs to be kept in the loop? It's funny using these kind of English language ideas to try to understand things, isn't it? Everyone needs to be kept in the loop. Don't know. Initialize to leader last log index plus 1. Last log index is here in the leader's copy of the log, plus 1 for the next index. But this is an array. It's per server, and it just says to lead. Does it mean it initializes to the last log index plus 1 for every server? I think that's what it means. We're working with a fixed number of servers, no changes in the number of servers. You can imagine how many how much chaos would be caused by a new peer entering while we have like an array of a fixed length for specifying what's going on with each server, and just sheer chaos. Bloody hell. Match index. For each server, index of highest log entry known to be replicated on the server. Highest log entry known to be replicated on the server, meaning that log entry is in the server, and I think an assertion is that every log is correct up to the point where it exists in the particular server, i.e. in order theory terms, because maths, of course, I would say that the logs are all related by extension. I was going to say something even stranger than that, but yeah, I would say all of the logs are related by extension. That would be the maths way of saying it. What that means is that if you take any two server logs from different servers, then one of them is an extension of the other one. Or they're equal, which is still an extension, trivial extension. So this is sort of knows about the log entry on each server, and this is talking about which one is the next one to send to that server. Volatile state. Oh, this is leader only, so the leader is communicating stuff to all of the other peers. Because don't forget, it's all replicated, all of the sending, in case something crashes. I don't even have a clear idea of how the whole replication thing fits with the idea of the key value service. I don't know enough about the key value service, but I'm not going to read that. I'm just going to take it for what it is, and maybe later I'll read it, maybe for a bit, I don't know. But for now, I'm not going to read it. So those are the state variables. Bloody hell. What else do we have in this document? Append entries RPC is like the main RPC type, the main message that is sent. Invoked by leader to replicate log entries, also used as heartbeats. Yeah. The empty append entry is a heartbeat, it says it here. But it's only the leader that sends append entries RPCs. And this is what it sends. It sends the term of the leader. The leader, follower is a name for a peer / server that is not the leader. Follower, okay. Drone, I might have called it. Drone. Leader ID is, I guess, like the address of the leader, so the follower can redirect clients. We're getting there now. Does a client access an arbitrary follower at random and then get redirected to the leader? Things that make you go, Previous log index of log entry immediately preceding new ones. No idea why we need all this stuff yet. It probably says it in the rest of the damn paper, which I should maybe sit down and read, but not before I've tried implementing it, I'd say, because that would slow me down. I think it's faster to try first. Previous log index of log entry immediately preceding new ones. So don't forget, leader is sending this. This means that everything is contingent on the status of the leader, what the leader thinks is going on. Index of log entry immediately preceding new ones. Term of previous log index entry. It's not completely clear to me what has been completely agreed and what hasn't at what point. So there should be an assertion that certain bits of the log are identical across all the servers. So in maths terms, I would say the intersection of all of the logs. The intersection is, of course, in the sense of extension a minimum, right? It's the minimum of all the logs, the shortest log. It is compatible with all the other logs, but by virtue of saying that, that means that everything there is like objective fact data, stuff that it doesn't matter according to who you ask what's going on, you'll always get that answer. And what I'm saying is it's difficult to identify what comes under that by reading the guide here so far. That's what I'm thinking. Log entries to store, empty for heartbeat, may send more than one for efficiency. Okay. Leaders commit index. Index of highest log entry known to be committed to the log is the leader's commit index. Result. Current term for leader to update itself. What is that according to all the followers? They have their own term. And success is true if follower contained entry matching prev log index and prev log term. Oh, immediately preceding the new one. Oh, okay. So why is it successful? Because the follower the leader is communicating with is up to date, is what they're saying, because it has the same previous log index and previous log term as the leader. If the follower contains an entry matching that, so it's not necessary for it to be the last entry, it should just contain an entry matching the last known thing according to the master, the leader. Not really a master because the leader keeps changing, that's why it's called the leader, I guess, just in nomenclature. But yeah, it's successful if the follower is up to date, that's kind of what this says. Receiver implementation, this is the receiver of this RPC, which means that all the followers, but I mean, you know, literally every server runs exactly the same code, and so this is just, if it's the follower, this is how it's behaving. It's doing the receiver thing. Reply false if this is not true. Reply false if log doesn't contain an entry at prev log index. Oh yeah, at the login, so it should be at the index whose term matches log term. If an existing, it's going to be difficult to reason about why it works. This is the thing about all of this stuff, even if I implement it correctly. If an existing entry conflicts with a new one, same index but different terms, delete the existing entry and all that follow it in the follower. Yes. Sick, that makes sense. Because the leader is the one that defines how the log should be. Append any new entries not already in the log, as sent by the leader. If leader commit is greater than commit index, you know, leader's commit index is greater than the local commit index. Commit index is index. The names are annoying because it's like, why aren't they both called commit index? Index, for example, and then I could just reason one of them is commit index and the other one is apply index. Applied index, as in last applied. So yeah, I wish they'd named this apply index. I guess I will eventually get used to what the alias, well, what means what the names of the things are. At the moment, it's a struggle to remember anything. It's all just a hodgepodge of stuff. Results. Term success. Yeah. Sorry, we looked at that, even though I barely remember it. Yep, if the leader commits, so if the leader thinks that it's pushed more to the log than the follower, then the commit index matches the leader commit slash the index of the last new entry. Because we let the leader update itself, and we update ourselves as well, as in from the perspective of the follower. Okay, I've read half of it. Whoa. That is append entries RPC. There is also a request vote RPC, which is all this stuff. Invoked by candidates to gather votes. This is useful as, useful as fuck. I'm gonna leave this table just lying around. I wish I could just print it, to be honest, and put it on like my bedside so I could just look at it anytime. But no, I may as well do everything on screen. So I'm gonna keep referring to this document. It seems like it's gonna outline pretty much everything. Request vote RPC. Invoked by candidates to gather votes. What is a candidate? Not clear yet. Argument. The candidate's term, the ID of the candidate requesting the vote. Obviously, if the leader fails, then a new leader is elected, which means that votes are initiated by non-leaders, possibly also by the leader, but I don't think votes are initiated by the leader ever, because why would you do that? There seems to be no point. Leader confirming itself is not really necessary to do via a vote, as long as heartbeats are happening. Oh yeah, we said, didn't we, when reading the other stuff, that if heartbeats are received, then basically all of the followers continually request votes using a timeout that keeps getting delayed every time a leader sends a heartbeat. So it's the leader is sending heartbeats so that we will know that it's in touch with us. And the heartbeat is just an append entries RPC. So if the leader sends an append entries RPC with an actual entry in it, that's like a heartbeat in and of itself, except it also carries data. And so that also tells the followers that the leader is still up and at them. So, okay, so I do understand that. I understand what circumstances the vote is supposed to be called under. So let's see if that means that I can make sense of what request vote is talking about. Candidates send request vote RPCs to each other. Yeah, not to the leader, because then it's a situation where the leader stopped replying. So it sends the request vote RPC to literally every other peer that is around. Just sit up a little bit. Lighting is a lot better in the morning. I appreciate that, but depending on timings, I may not always be able to work in the morning. But tomorrow morning I'm working. Well, 12 to 2 p.m. So all good. So I will definitely go for it then. As in, I will definitely have some natural light, and it will all be swell in Sesh 3, which is tomorrow, 12 to 2 p.m. Candidate sends out its own term. It sends out its ID. The ID of the candidate requesting the vote is contained in the request vote RPC. Last log index and last log term tells you the term and the index of the candidate's last log entry. So we're completely clear. Index and term are not the same thing, which is something I said earlier. But just so we're clear, this has been confirmed. Confirmed. Like shiny Kyogre. Confirmed. The candidates, as in the current candidate, the sender's last log entry. That's all stored in there, because I think the one with the latest one is voted for. That's probably how the vote happens. Results. Floor just popped. Spooky. Results. Term. Current term for candidate to update itself. Who the hell replies with the term? vote granted true means candidate received votes from that automated voting system is not exactly how democracy works. It means that the candidate received a vote from whoever it sent the RPC to. I think it sends the RPC to everyone and decides it's the leader if it won a majority. And there's probably an assertion that means that only one leader gets elected, which is one of the in part 2A. That's one of the tasks that's actually important to get right, if you recall. Yeah, I'll just have the laptop in shot slightly there. No problem. Okay, that checks out. Receiver replies false if the term is less than the current term, which means that the voter it means that the candidate that sent the RPC is outmoded, out of date, you know, Jacob Rees-Mogg, that. It's a candidate that's not getting votes because it's not with it. It's not with the kids. It's not down with, well, as in the thing that's asking for it to vote is more in the future. And if it doesn't even know what the voting session is, does not receive a vote. Reply false. Well, as in it replies vote granted equals false rather than, and then it replies with the actual term. If voted for, what the hell is voted for? Oh, it's a persistent thing that. Oh yeah, okay. Every candidate has. Well, no, sorry. Every peer has a persistent, constant, consistent, persistent voted for variable that stores the server that it last voted for. If that is null, as in if the thing that the candidate asked for it to vote for a vote from. So to be clear, took a breath so I could be clear. Request vote is sent by the candidate to I think every other peer, and so in the context of one request vote, there is a candidate and a voter, a candidate and a voter. And so we're talking about the receiver is the voter. We're saying reply false if the candidate thinks the term is before what the voter thinks the term is. And if the voters voted for is null, or candidate ID matching the candidate, so it's voted for the same candidate, and candidate's log is at least as up to date as the voter's log, grant the vote. This is so similar. This is extremely similar to, well, extremely is a bit of a strong word, but it reminds me a lot of the algorithm that I implemented for deciding when to update raids in the raid bot that I did, Rio. So as a brief excursion, let me just dig up the code and show you what I mean. Rio. So this lovely little bot that I made has a should update function, which is present I think in index. So it's a very short deterministic pure function that looks at, here it is, it looks at whether or not a new raid that has been received is actually new or not. So the point is the source it's pulling data from doesn't send new data. It just sends all existing relevant data. Almost all of that is stuff that the bot already knows about. And so this is when it figures out if it should update using a new piece of data a particular node that stores data. So the data is always matched to particular nodes. Gyms. So it's basically matching raids to gyms. That's how that works in the actual game. And so we have all these criteria, right? It returns it. It has to pass all of this stuff in order for it to return true. So for starters, the current time has to be past the time that we know that the previous data is valid until, so that it doesn't even try to update it if the old data is still relevant. And if that is passed, if the previous raid is not obsolete, if there has not been a raid at all at that gym, or if the previous raid ends before the current raid, or if the both of the raids end at the same time, but the actual raid, because raids are two-phase things, there is first an egg and then a hatch. So this checks if that has happened, and so it's I'm not gonna explain it completely, as in I'm not gonna elucidate it further, but it's basically just it finds if a raid is genuinely new information by looking at comparing the data sequentially. First of all, is it even worth checking if it needs updating? Because it won't need updating until a particular time, and we can determine that in advance. That's why that works. And then if there is no raid information, then definitely the thing is new. Or if the raid information that's there ended earlier, that means we have a new raid. Or if it's the same end time, but one of them has progressed. It's in the boss phase rather than the egg phase. So, okay. Bit of an excursion, but that is what it reminds me of. That's why I brought it up. Looking at the it's open and edge, isn't it? Because this is kind of similar in the sense that we care about. We're looking at a single interaction between a candidate and a voter. And when does the voter think the candidate is up to scratch? If it thinks that the voting term, which is the round of voting, I think, is at least as in if the candidate thinks that the voting term is at least what the voter thinks it is, so the voter is happy the candidate's up to date on the term, and the voter also has to be happy the candidate is up to date on the log, right? So the candidate's log has to be up to date with the receiver's log. And that will happen by checking some of the log variables, which we'll need to look at. Probably commit index is the one you want. I'm not sure if that's entirely all that is necessary, so I'm going to be doing some detailed sketching where I try to figure out exactly what determines, the exact details of how we know something is up to date or not up to date. So in this case, if the log is up to date, how do we know that? How can we check that? That implementation detail I'm gonna be doing during the upcoming sketch phase, I guess. Just gonna move the microphone, bear with. Yeah, just so I can slink back slightly further. Sort of sit back a little bit in this direction, because my butt's starting to hurt again. Yeah, the butt hurts, the butt hurts. Yeah, fucking dead numb butt. Half an hour left. I might just finish drafting, trying to process what's going on. Rules for servers. Damn, there are fucking. Look at all this. This is like the list of hints, isn't it? I guess it's quite similar. Assertions. So many assertions. All servers, if commits index increment last apply to state machine. Yeah, the apply to state machine is done via sending to a channel. What's the name of the channel? It's not even written here, is it? This is a separate set of notes. It's written in the interface that we have the apply ch, which is how we apply to channels. To state machine. Convert to follower. There's a situation in which things are converted to followers. Stuff that followers follow, stuff that candidates follow, stuff that leaders follow. Okay, I'm not going to read all of that immediately. I don't think it's necessary. Because I think what we have already is enough to sketch out the general gist of how the whole algorithm works. I'm feeling like I do have enough to finally get my oof, fuck this. I need to deal with my ear. I just prodded it and it hurts, as happens sometimes. I think I have enough to sketch the gist of the algorithm, so I'm gonna pause with the reading and just look at append entries RPC, request to vote RPC, and we also have the RPC that isn't mentioned here that commits to state machine, apply entry, or something along those lines. It's apply ch. In the case of the implementation here, apply is just send to a channel rather than an RPC. It's a bit different, so maybe I won't call it an RPC, but it seems to serve a similar, work in a similar manner. I'm going to move to a slightly more comfortable position. I've just tilted myself, actually. Literally twisted myself in order to get to a slightly more comfortable position. But I think this is still cool. I wish I could move the microphone in a bit. I can swivel slightly, just so I'm vaguely speaking at the mic. Okay. Yeah, pushing through. Unfortunately, not in this stream. There aren't too many natural breaks that I can make. It's all about the reading. It's all about internalizing what's going on here, and there is a lot. So I'm just trying to figure out how Raft works. Have about another half an hour, so let's. Should be about 127 of streaming so far. Indeed, it is. All good. 0 dropped frames, impressive. Laptop is, no, I'm impressed. It's keeping fairly cool. 80 degrees or so at most, but like, yeah, fan is not too loud. Obviously, fan has to be on if you're streaming on such a small laptop. I mean, I did start out a Raft sketch, if you remember. So let's see if we can continue that. Servers, there is one leader dynamically assigned. This isn't going to tell us too much. Instead, let's break down the RPCs that are defined here. Append entries RPC and request vote RPC, okay? I think those will elucidate quite clearly what's going on. So again, I'm not looking at the details, I'm just trying to get the gist of how they work. So, important details. For starters, who sends the RPC to whom? Append entries should be quite clear. The leader sends to... Well, okay, actually there is information on that here. You know, send initial empty append entries RPC to each server. Every server gets it except for itself, I guess. You know, send append entries RPC with log entries starting at next index to a follower, not to every follower, but it thinks it knows which followers it's supposed to send it to because it has, yes, it has next index, which keeps track of the leader has these two things which try to keep track of what all the followers are doing, including itself, actually, all the servers. And so it uses that in order to try to define when it should send stuff, which I guess is just so that it doesn't keep sending redundant data. Right, obviously if the last log index is less than the next index that the follower expects, there is no need to send out the message because it already has it in principle. So I guess it's just a way of saving bandwidth. Because certainly the algorithm would still work if it kept sending it to everyone, but then the follower would have to keep discarding the information. Although, because this is a distributed system, um, it is certainly possible that the follower receives something that the leader thinks is new information for the follower, but it's not actually, and then it discards it anyway. But the leader gets updated. I don't know, something along those lines. So lots of fragmented thoughts that I'm just trying to condense at the moment. But yeah, basically, leader sends to certain followers. Heartbeats should be going out to all followers. If there's a lot of data, you can see why you shouldn't be sending it all at all times to all followers. But heartbeats are empty. Append entries RPCs. Let's copy that again, just because I think it's quite an important thing to remember. Do not forget this detail. I think the thing is actually called append entries, but never mind. Shouldn't be too ambiguous. Maybe I'll rename it here, but not there because in case I got it wrong. So because the heartbeat is an empty one, it should be sent to all. It's heartbeat to all. But it's just, it's important to remember that only the leader is entitled to send those RPCs. Sad times if the leader gets detached from the rest of the cluster and then it's like, it's doing its thing, sending entries and things. It's quite biological almost. It's doing its thing, but it's completely futile because it's not part of the system anymore, but it doesn't know that. I guess it's kind of like if you had an organism that has multiple brains. I'm not sure such a thing exists in biology, but if you split it and one thinks it's in control, but it's not anymore, it's this kind of tragic situation. But this is how it works essentially. Yeah, so there's a lot of biological analogy as well as the democracy analogy. Um, let's keep reading. Yeah, keep flicking. Where did I put it? In edge here. Keep flicking through. Put edge up the front here. Invokes by leader to replicate log entries. What was I typing in? The sketch. Yeah, that's it. Sorry. So I can now alt tab cleanly. You wish you could. No, you can't. Okay, got the alt tab working. Between the important stuff. Yeah, so append entries RPC. Let me try to increase my thinking speed. I'll try to get less distracted by my dodgy eye. Leader to certain followers, heartbeat to all. Two, so purpose, to replicate log entries to, all the copies of the log on all the followers. Heartbeat to stay in touch. What that means effectively is going to be about delaying re-election. Then there are technical details here, but let's allow those for the time being and look at request to vote just to get the outline as well. Invoked by candidates to gather votes, right? So to gather votes for itself. Candidates, literally everything sends out request to vote RPCs once the heartbeat times out. I think that's the general gist of that particular functional loop, how things are working. Oops. Ooh. Box has slipped slightly, just got to be careful. Very slippery. Where is the... Oh, it should be landing on the hinge, shouldn't it, which is here. Cannot see what's going on. This dear lord fucking box. Sorry, nudged the microphone. Okay, that's good. Maneuverment. Candidate to voter to gather votes for itself. How next do I process the information? I think rules for servers is fairly... Well, what are the main sort of processes, like conceptual processes? Re-election when follower does not receive heartbeats slash... Okay, I'm gonna say heartbeats is... No, I can't. That's going to be a conflict of notation. I've said heartbeats is an empty entries RPC. Empty append entries RPC. So instead I'm going to call append entries is going to be used to signify the whole thing, whether it's a heartbeat or it contains actual data. In both cases it's an append entries from leader. Follower, yeah, doesn't. Just want to compactify it so it fits. Re-elections when follower doesn't receive append entries from leader. That's an important one, and the other one is leader sends updates followers on log progress. Whew. Woo, lads. Bloody hell. Understanding this, mate, is not easy. All servers. If commit index is greater than last applied... God, I need to go over all this stuff again in order to understand it. What these fucking state variables are, what they do, what the arguments and results are. This should not be so difficult. Let's reread the state variables again. So every server contains, let's ignore persistent and volatile for the time being, with the distinction between the two, with the idea that nothing fails. We're assuming that nothing fails in order to simplify things. Even the first task, I think something failing is going to be tested, but for the first step of understanding, assuming nothing fails, much like we did in MapReduce, I think is an important, useful step. So we don't distinguish persistent and volatile as a result of that. Well, we won't need to distinguish those until task 2C anyway, I don't think, but you take my point. So we have some state variables for leaders, that's fine, but let's look at all servers first. Latest term server has seen. So general state variables. Let me try to. I'm gonna bullet this just to make it clearer. Even though that pushes things onto a new line, I'm sure I can just fudge that. Replacing when with if in this case, which is good enough. Because they are lists. These are not lists. They're just the sender, receiver, and the purpose. send receive, purpose. So yeah, just a bit of formatting to keep my thoughts in order. Wah! Okay, so the general state variables. Current term, voted for, all the stuff that needs to be kept synchronized / not necessarily. Commit index, last applied. Slightly difficult to type on this laptop in this position, unfortunately. Alright, so this is what all these things are. Latest term server has seen. What I think the term is, details 0, monotonic increase I'm just gonna write as ++, as my personal abuse of notation. Sorry for not making it generally understandable. You know what, actually, I can just get a fucking up arrow, can't I? And use that as the notation. I think that's pretty legitimate. For a monotonic increase, up arrow is the one. Yeah, so now it's going to give me this shitty warning, and so I just resave it in Unicode. I cannot understand why Unicode is not default in Notepad, much the same way as I cannot understand why it does not respect standard line breaks. So yeah, it starts at 0 and then increases. Voted for. Candidate ID that received votes in current term. Candidate ID that received votes in current term or null if none. That should definitely be initialized to null. It says in current term. Candidate, every voting round should increase the term, but I mean, voting rounds are triggered independently. There should be problems, I guess, if voting rounds coincide with each other, and it is possible for that to happen, unfortunately. That is a race condition and a half, if voting rounds coincide with each other. Cannot tell you how that is dealt with at all yet. What I vote, who, sorry. So, who is the person, i.e. the server. Who I voted for in current term, slightly loaded reinterpretation, could be wrong. But I don't want to tread on eggshells too much if it is wrong. I'm being bold. I will hopefully not get confused by my own interpretation, and we'll be able to change it as and when. Log entries. Each entry contains command for state machine, I know. So that's just the data. It could just be string as far as this experiment is concerned. It is serialized, and so it is a string. Term when entry was received by leader. My log copy. Command, which I'm going to write as data, and term when entry was received by leader. Data, let's write it using some sort of object notation. Data, term in which leader received it. What do you mean first? Yeah, not monotone. But what do you mean first index is 1? I guess in the log. Log starts at 1. That's a piece of information I'm going to just omit for the time being. I'm not convinced it's important. Highest log entry known to be committed. Highest log entry applied to state machine. Index, I think, is latest logged. So I'm using log as a verb to mean committed to log. Dark light outside, darkness on the estate. Somebody just shone a smartphone screen through a window. Looks a bit creepy. I'm just looking at them now. Probably won't look at them too long. But it's how you draw attention to yourself, I guess. Ooh, spooky. Last applied. Index, I think, is last applied. Latest applied. So I'm using logged to mean logged to the log. And I'm using applied to mean logged, well, not logged, but like sent out to the state machine then. This is all stuff that is in principle one brain, but is split across many brains, and it's all about keeping them synced. This is a proper distributed system. This is what I came for. So it's quite cool, isn't it? So this is the general state vars that are maintained by everyone. Okay. Let's put down some leader state vars as well. You know, this is just what the general state vars. That's variables. Var meaning variable. The general state vars. Those are, you know, everyone's interpretation of the world, effectively. The state, the current static situation. Leader has a couple of other things it wants to keep track of itself. Reinitialized after election, obviously. Reinit after election, but that's obvious. Next index and match indexed. Tracks. Peers. These two track the peers. For each server, index of the next log entry to send to that server. Index of the next log entry to send to that server, and index of highest log entry known to be replicated on server. Just had a side thought now that I'd love it if I could do a proper debug full introspection where I could see exactly what all the variables are at all times, like a demo of Raft. Maybe that's what Figure 2 does. Maybe I should flick through that now. Figure 2, not Figure 2, the illustration that was up in the problem sheet, if you remember. But it would be lovely if while I'm implementing all of it, I could debug and just see it all happening. It would be so cool. But there is an illustration which I guess is good enough proxy. So okay, each server is being tracked by the leader. Index of the next log entry to send. Next log entry to send. Index of next log entry to send. Index of highest log entry known to be replicated. Latest log entry peer has. I'm just going to use the words peer has to mean is replicated on that peer. So we have here the RPC implementation details. Instead of doing that, now that I've re-summarized this, I'm a lot more confident in understanding the state section. Let's look at the rules. Because I know the names of all the variables. That's important. Current term, voted for, log commit index, last applied. These are both indices. I really wish. Oh no, moth. Plus, piss off. Why? It's just going up. It should be going down, but I have the fucking lamp on. Do you know what? I am. Sorry, bear with me. I'm going to try to kick out the moth. The only way is to turn off the light and hope for the best. So get out. Yeah, this is another reason I really prefer morning sessions. Whoa. It's a jumpy. This moth is jumpy. Oh god, the problem is that the screen is on. Do you even see the moth, guys? What the oh, there it is. The struggle is real. It's just in my room now. Well, there's nothing for it. Once I'm done streaming, I'm going to turn everything off and open the window fully and hope it leaves. That's realistically the only way of dealing with something like that. Moths, not happy. They eat clothes. I have this lovely woolly hat. Woolly hat. Don't want it to eat that. Let's take the hat off, just for a bit. Chill out. Do me hair. What hair is there to do? Like I said, I just had a shower. Well, not a shower. I just washed my hair. Look like I have a receding hairline almost. I don't actually have a receding hairline. Well, to an extent I do, but it's not that receding. But you know, aesthetically, I don't mind having a bit of recede. But I'm definitely gonna bitch about that if I get a proper receding hairline. Like I've actually seen that on some of my like friends and acquaintances, and it's not a pretty sight. But it's also nothing to stress about. Big learning experience is accepting a receding hairline, going bald in some cases. Chill. I'll just move the microphone. I can, I can move the microphone just by muting it temporarily. Don't want to get too perfectionist over a freaking microphone. But yeah, I notice if it's too close to where I'm sitting or have my elbow, then it gets moved loudly, like you hear it through the microphone channel. It gets moved up and down by the bed being, quite elastic and unstable in that sense. All right, concentrate. Whoops. When I say concentrate and that happens, it's not the one, mate. It's not the one. What I want instead is to be able to Alt-Tab efficiently again. Okay. All servers, followers, candidates, leaders. So notice there's nothing about voters. But that's because voters is basically just described in receiver implementation of the vote RPC. And the receiver here is the follower, so there's a bit of information here, but yeah, respond to RPCs from candidates and leaders. Well, of course. Okay, listen. If that's not Control F, then what is this fucking toolbar? Can I get rid of it? Does it go away? Yep, just tap the body. I was about to whinge about Edge being bad because I couldn't get rid of the thing, but it's okay. It disappeared. Yay. Okay, the all server assertions are going to be quite important, I think. They're going to cover pretty much everything. State, vars, general. Where did the cursor disappear to? Leader. So just gonna make this a bit compactified. RPC outlines. Just cleaning things up a little bit, removing the redundancy. as you can see, everything is a bit easier to read now. Maybe I should be using Markdown or something so that's slightly richer, just to make it a bit clearer, but no problems at all. Okay. Yeah, I'm happy to leave that there actually. Nah, it's just a bit of a distraction having Streamlabs open. But when I alt tab, it doesn't minimize, so I have to be careful when alt tabbing. Okay. So some of the general assertions for servers: if commit index is greater than last applied. So those are the two indices here. Increment last applied, apply. Should there be a go routine that's constantly doing this? Probably yes. Increment last applied, and also do the application to the state machine. Yep. Okay. I'm just gonna write some general notes down here. Self assertions. Not necessarily even assertions, self doings. I'm gonna put if commit index greater than last applied. I have always in my life I just visualize number lines, and that's why I absolutely hate using greater than. In pretty much every circumstance, I try to use less than when I can. Other than if I'm doing case by case and have the same things on the left and right, then I'll do greater than, less than, equals. But other than that, I tend to really prefer using less than. serious look, less than, not more than car insurance or whatever, less than. Last applied, plus, semicolon, commit. Apply log last applied. Sorry, eyes again. Now they've just dried out. Increment last applied. Apply log last applied to the state machine, which is to say, apply is the verb I'm using to mean the state machine, don't forget. Apply last entry, which is log at the index last applied. Log starts at 1, that's fine. The zero value in the zero indexed thing in the array or list or whatever is just going to be some null value, doesn't matter. I used to do those as well just to keep things neat so you don't get index shifts off by 1 errors. Just put some placeholder in the 0 slots if you need it to start at 1. That's the way to do it. If RPC request or response contains term T what? Yeah, I guess that makes sense. Which RPC is this? Is this any RPC? Well, literally all the RPCs result in a term. This is the thing, every RPC ever sends a term and receives a term. Okay, so the send term is what the sender thinks the term is, and the receive is what the receiver thinks the term is. So the point is the self receives from an RPC information from the thing it tried to communicate with, and it updates itself accordingly. Which is to say, whenever an RPC is sent, the sender gets information and does something. The receiver, when an RPC is sent, the receiver doesn't usually do something directly like that, but sometimes it does. Well, okay, it replies stuff, obviously. But also the receiver, in the case of a heartbeat, the receiver should delay leader election. There are a few cases in which the receiver actually does respond. Other than just directly replying, it does something else to an RPC. But for the most part, I think the idea is that the sender is the one that sends information, gets information back, and acts accordingly. I guess in the case of append entries data transfer, the receiver should be also taking advantage of the data, which is much like saying the receiver should use the heartbeat to delay leader election. Yeah. Okay. No. I feel like I am actually making progress. I think I might keep going until I feel like I have a solid overview of how Raft works. I feel like I might even be pushing forward. I might even be pushing forward in the sense of outlining everything to the extent that when I start implementing projects A, B, and C will just be one after the other after the other. Won't require too much more understanding because it's not really that granular. I think you have to understand more or less everything, or at least I feel like that's the way to do it. I feel like I would prefer, rather than my initial idea of just hacking the implementation and seeing if I understand it, going a bit more old school with the theory, just modeling it and reasoning through it and using that to sketch the entire program and seeing what happens. And I'm definitely making progress though, so I'm keeping hyped, keeping excited. Well, yeah, I'll figure out later how to split this into sections. This stream it's going to be difficult. I might not even be able to because I am just reasoning through everything. Um, literally every RPC does a term comparison. Do I add the conceptual process with that? Not necessarily. Let's just put it in self-doings for now. Unfortunately, there is no way of shortening this. I have literally the bare essentials of information. All that I can do is make it slightly uglier. Never mind. I think it's okay. For RPC request or response. What do you mean request or response? Surely term is in the request. And then term is coming through the response as well. Yeah, but what? I'm slightly confused by this. We're communicating terms. What I think should happen is that whatever the term variable is in any of the servers, if a server sends an RPC, it sends that term variable and the receiver responds with its own one. And the point is, I guess both the sender and the receiver actually update, despite all that I just said about the sender being the one to act. I think both of them update themselves according to their own terms. Oh, I guess this makes sense then, because it's like, term and current term comparisons are done both after the send and after the receive, after the response. RPC is always a two-step process: data sent back. It's like a handshake almost, mutual. And so on the send, the receiver receives the term from the sender and compares it to its own term. And on the response, the sender receives the term from the receiver and compares it to its own term. So in that way, whichever one has the later term propagates it, synchronizes it with both in one RPC call. So RPC is synchronized terms. That's, I feel, quite important actually. I just said 3 words and they're pretty important. RPC's synchronized terms, okay? I'm going to write that down. This seems like an important concept. Let's just put it somewhere down here. RPCs, all the way down. Synchronize terms. Okay, let's try to elucidate that technically. If RPC request, so the request is compared at the receiver end, the response is compared at the sender end, so what we just said. And term is the thing that arrived or was sent out, and current term is the thing based at the place where the comparison is happening. Set current term equals t and convert to follower. All of it's about monotonicity. The point is the term is bigger. We set it to the maximum. That's a general monotonicity idea. Everything is always increasing. We don't go backwards with the term at any point. No term comparison should result in a decrement of any sort to the term. But the way this has been phrased is important, though. It's if term RPC, so what that means is what the RPC sent is less than, sorry, other way around. If current term is less than the term received by the RPC in either direction, so again, RPC is more a bidirectional communication, much more than I thought it was. It's just that the sender initiates an RPC. That's what makes the sender special. Something initiates a bidirectional communication. First the send and then the response. If current term is less than term, then current term equals term. It's not just, yeah. There's an increment happening here. But that's because this might happen multiple times if last applied. If commit index jumps out like really far, then this could happen multiple times. This is just a kind of flushing. Think of it as a flushing again. Things in the log should be sent out by every server to be applied to the service, to the state machine. Every server should be doing that, and if it ever gets backtracked, it needs to be always flushing. This is flushing. Flushing, right? I want to emphasize that this is what that is. You can emphasize it without using so many words. Sorry, letters. Whereas this is state. No, term synchronization is what this is. If current term is less than term, current term is set to term. I am now follower. Okay, does this make sense conceptually? Does this fit into what we think should be going on? I mean, kind of. Yeah, it's going to require analyzing both the send and the receive side separately, unfortunately. So let's consider a send. I send what I think the term is, and the receiver receives it. So what this is saying is if the receiver's term is less, then the receiver is now a follower, and it updates to sync the term. And then when the term is sent back, because they are synced and hopefully nothing has changed, well, it can't have. It can have. In the meantime, the term could have gone up on the sender end, but that doesn't matter, because the receiver sends back the same term, and if the sender term has now gone up, it doesn't matter because it just will get ignored, because the incoming data has priority. So when the when the reply happens, the incoming data, if that is above, it sets off a change, or otherwise it doesn't. But that's obvious because each thing is trying to update itself. So current term is its own state variable, whereas term is the thing that the other thing is saying, have you considered updating to this? Okay, so that makes sense. In the case that the receiver starts out with bigger term, the sender sends the term, the receiver says, "Oh no, I have a bigger term," so it doesn't update it as its own term, but then it sends back its own term, and the sender does the update, and the sender is now follower. The point is, the one that is the follower, the one that becomes the follower, is the one that previously had an out of date term that had to be synchronized. So the thing that has a higher term should in principle be more likely to be the leader. The thing that is more up to date, the thing that is at the cutting edge, is supposed to be like the leader. This is my interpretation of what this means. This is the term sync. Let's just add the notes. My tongue is drying out now. It's all going wrong. So much talking, trying to understand this. Old. If my term is, so I'm thinking from the perspective of an arbitrary server when I use the first person pronouns I and my and me. If my term is old, I should be follower, but of course whenever an RPC happens, that results in a synchronization of terms anyway. Whether or not it's a vote RPC or a data transfer RPC, both of those do the term synchronization, and that's why it's important to have term. Candidate's ID is like, I know what this it's like a from field in a message. Term and candidate ID constantly getting sent out. Why is it prev log index, prev log term, and here is last log index and last log term? I just noticed that. I don't know if that means it's different. Who knows? But the point is, just break it down, right? Arguments for both append entries and request vote RPCs, both of them, two of the arguments are what I think the term is and who I am, and the response is what the other one thinks the term is. And that's a kind of generic, what happens in both of these RPCs and is separate from the actual intention of the RPC. The point is RPCs are being used, just, by the way, closing the window, the moth can fuck off. The RPCs are being used just by the way, regardless of their ulterior purpose, their main purpose. They're being used to keep the terms synchronized and to, the term sync decides effectively who should be follower. It doesn't, I guess maybe it's not the only thing that decides it, because there should be leadership elections, but if something gets set to a follower, that is one of the ways that can happen, probably the main way that can happen. So I guess, yes, getting set to leader is probably the result of an election. Getting set to follower is probably the results of being out of touch with the term. It's another thing that I'm just going to chuck in my notes here. So all RPCs synchronize terms regardless of ulterior purpose. And the thing that I just said now is that I become leader if elected. Democracy. I become follower if term is out of date. I'm going to use out of date. I'm just going to write that as OOD, which is an acronym I've been using since I was about 7 or 8 to just mark some of my old work when I was writing on paper. Like, I'd draw maps. I used to draw maps so much when I was a kid. And whenever I thought that a map had been deprecated and superseded, I'd usually write OOD in a rectangle or something. And so it's a term that goes back, OOD. So I'm happy to write OOD for out of date. Of course, I could also just write outdated, one words, but I'm gonna keep it personal and use OOD. Yeah, boy. If my because I did that because I want to say if my term is out of date. It's important. Check it. Okay. So that's the all servers assertions. Okay. A couple of important things about synchronizing terms between everyone and flushing data. Flushing data is something that everyone should be doing, and synchronizing terms as well is how I may find out that I'm no longer a leader, and that's why it's important, because there should only be one leader, or else God knows what happens if there's multiple leaders. So I guess that's why the term is important. The current term variable is managed by this, and also last applied vs commit index. This what this does is it basically explains flushing data, mate, what the hell? Flushing data basically explains the purpose of the last applied variable, which depends on commit index in that sense, last applied, and the thing that's edited, so last applied. And in this case, the term sync explains the current term variable. So I have that connection going, which is cool. Let's keep going. We have followers, we have candidates, we have leaders. Plenty of stuff to talk about. Let's just run through it all because now I feel like I'm getting it. Follower doings. So self, I'll just write general. When I think of the self, I'm thinking of Spave and Rakai, classic dubstep number. Well, dubstep. 133 BPM half time in it. It's not quite dubstep, but it's not dubstep anyway. It's like an electro soul song, but it's almost dubstep. It just has a displaced one beat, so it's like. Yeah, no beat on the one. Difficult to follow if you don't know what's going on. Just had a bit of time practicing that. Follower responds to RPCs from candidates and leaders. Does not even require talking about. That's implicit. Everyone should be responding to everything. Well, I mean, everything will be equipped to respond to stuff. It's just that if we look at the two RPCs, append entries, if something is leader, it should not be expecting an append entries RPC. On the other hand, the candidate voter stuff, if something is leader, request vote should not be being triggered unless that thing gets disconnected. So it's fair enough for it to always expect to receive a request vote, but all the followers should always be expecting append entries and request vote. Followers depend on append entries for their information, I think, and followers will receive request votes if it's relevant to them to try to elect the new leader. Beep beep. If election timeout elapses without receiving append entries RPC, this is what I mean, heartbeat or data, both of them are append entries, from the current leader or granting. Does the follower know what the leader is? Does it think it knows what the leader is? No, see, I don't think there is a state variable that tracks who the leader is anywhere, which is reasonable. I think it's reasonable because there's an assertion there's only one leader, so we don't need to check who the heartbeats are coming from to decide who's the actual leader. The follower just doesn't care because it receives heartbeats from somebody or data from somebody, and it always acts on that, even though it doesn't know who the leader is, because I think there is an absolute assertion that there should only be one leader. That's what's being tested by the testing library anyway, so that has to be the case, and that's presumably why it would be redundant to have a leader variable. Leader variable is easy to implement on the top of all this, just by saying the thing that I received the heartbeat from, that gets assigned to leader. And but if the leader changes and I don't know about it, then that doesn't work. Yeah, there can be a change of leadership without the follower even having requested votes, because it happened too fast for the follower to request an election. Therefore, I think there is no leader variable, as in none of the family, none of the fam keeps track of who the leader is for that reason, if that makes sense. I think so. Seems like a reasonable reason. A reasonable reason. Alright, check it out. If election timer elapses without receiving append entries from current leader, well, from anyone, or granting votes to candidates, convert to candidates. Okay? Followers only. Leader does not do that. Okay, follower. Candidacy. If timeout on two things, we're timeouting receive append entries, or, well, look at this. If election timeout elapses without receiving append entries RPC from anyone, currently I'm just going to assume it doesn't care. Although it might, in which case I'll be wrong, but I will be able to fix that, I think. No, like I said, not being paranoid about getting every sketch detail right first time. Current leader or granting a vote. So this isn't just receiving the vote request RPC, request vote RPC, but it has to actually have granted the vote. Grant, receive append entries or grant vote. Colon, convert to candidates. Become candidates. I want this to fit on one line. Candida dot whatever. There's literally just one character I need to trim there. I don't know which one. Yeah, this is okay. Okay, candidates doings. So there should be a few state variables, presumably, to track if something thinks it is a leader itself, if it thinks it's a follower, if it thinks it's a candidate. That stuff is reasonable to implement as a state variable, I think. Candidate doings. On conversion to candidate, start election. Initialize. Init, yeah, because the candidates the process of becoming a candidate should trigger a few things. Start election. How should I write this? With brackets. Some pseudocode. Current term is incremented, so it's leading a current term increment. You know, it's setting it out for itself. Votes, self vote, okay. Reset election timer. What the hell is the election timer? Is there a there cannot be a global. It's a distributed system. There are no global. There's no global anything. I'm thinking, what is the election timer? Don't know. Send request vote RPCs to all other servers. Send request votes. Yeah, I'm not going to be sending any RPCs to myself in any of these things. That's just wasteful and pointless. So I'm going to assume as a default that I don't send to self anything. Okay, that's okay. Send request vote to all. That is a lot of stuff to do. Okay, if votes received from majority of servers become leader. Let's do it step by step. So it's a majority among all the other. Oh no, it's not, because there's a self vote, so it includes itself. So yeah, there is actually an if majority that includes the self, or else there wouldn't be a self vote. If votes received from majority of servers become leader. So votes received, not replies, but like actual grant votes. So successes, true responses become leader. Okay, if append entries RPC, if votes received from majority of servers become leader. If append entries RPC received from new leader, convert to follower. When is that RPC supposed to be received? At any intervening time? Slightly ambiguous. You know, all of this stuff is sequential, absolutely sequential code, but this is, you know, append entries could be received at any time during this process, the start election process that I'm describing now. Received, convert to follower. So there is another way to become a follower. If election timeout elapses, start new election. So that's election timer, election timeout. Or okay, new is, yeah, I should use the word new. I'm going to split it up like this. So when it becomes a candidate, it starts an election, and this is what start election is all about. And I'm going to, yeah, using standard notepad, I have to use some manual decrement process, de-indent process. So yeah, that's sequential code, no need for this. But what I will do is actually put these in. Yeah. Yeah, start new election. So again, I don't know when this happens, becoming the follower. But it's just one of those things that is trying its hardest to not lead to there being multiple leaders. You know, it's possible for various things to receive a majority, but if the send of an append entries is done fast enough, something becomes follower. But that's before it can start sending append entries. This is the thing, so I think this should happen at the end. This is an interrupt, but if it has become leader, it does not unbecome leader. It is then the leader. It is still possible for things to simultaneously become leaders, but then, okay, then what happens? Because they received append entries RPCs, they both become followers. They probably will have sent each other append entries. They will both become followers, and then everything will start triggering votes again, and so a new leader should happen. I guess this is why it's important to try to desynchronize when the leader elections happen. generally speaking, that was a thing that was mentioned earlier, I remember. But nonetheless, this isn't really something a candidate should be doing, becoming the follower. It should be every time an append entries RPC is received by anything, it becomes a follower. What I said here is that things become followers if their term is out of date. But what about receiving an append entries RPC? Does that make something a follower? No, not necessarily. What happens if an old leader comes back? It sent an append entries RPC and then the actual leader became a follower. Is that valid? It would require resyncing. At this stage, it's definitely not all going to be completely transparent how it works, but we're already in a much better position than 2 hours ago. Okay, let's look at the leader. Leader doings. What does the leader do? Yeah, this is not exactly clearly written because the votes received from the majority of servers obviously comes down to this. All of these three have to be, I think, exit conditions for this because it's not staying, in no cases it's staying a candidate, except if the timeout elapses and then it loops. So, yeah, I don't know why they've written it that way, but I kind of understand actually. This is the election rigmarole, the election legwork, and then this is the cases of things that can happen to something while it's a candidate, like say receiving votes, of course, but also receiving append entries. Oh dear, and timeout elapsing. Just restart. Okay. Oops, sorry. What I do, what I do. Da 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 da. Okay, leader doings is what we're looking at next. Okay. Upon election, so that is init, because I'm pretty sure the only way for something to become a leader is being elected. That's, I think, honestly inherent in the name, more or less. Leader init. Upon election, send initial empty append entries, which we defined as heartbeats, to each server, and this as well, just bracket heartbeat. Send heartbeat to each server. Repeat during idle periods to prevent election timeouts. Okay. Start heartbeat loop. No, okay. Send heartbeat to all. Still alive. Still alive. Oh yeah, I guess I should set it out a bit better. Still alive. What that's about is send heartbeat to all during idle periods. Else sending this. Right, this is a kind of comment rather than a specification. Else sending data, i.e. append entries. That's to prevent election timeouts, of course. If command received from clients, append entry to local log, respond after entry applied to state machine. Yep, the communication between the client and the state machine, which this is an intermediary between, right? Absolutely. Sorry, again, struggle with Notepad. So many things to click on. Client requests. Append to log. Append to log. Local log is implicit in that, absolutely. And The command received from client, append entry to local log, respond after entry applied. Respond after entry applied to state machine. Append to log. Append request to log. And it should also be responding upon applied. Respond after entry applied to state machine. So I guess, yeah, the state machine communicates back. You know, everything is sending, not via RPC. Well, probably in a real implementation via RPC, but don't forget to send things to the state machine, the service. We are actually just sending it into a channel called apply.ch, the interface channel with the state machine slash service slash key value thing, which is the example that's going to happen in part 3 of the project. In all of those cases, there will be replies received. No matter who sends it, they'll get a reply saying it has received it. And so if the leader does that, the leader communicates with the client, responding upon applied entry. So yeah, this is requested entry, I'm pretty sure. And yeah, respond upon applied entry. Okay. If command received from client, append entry to local log. Respond after entry applied to state machine. Yeah, just to be completely certain I understand this. You know, the command is the entry, okay? Received from client, that is appended to local, and respond after that entry is applied to state machine. So append requested entry to log and respond upon applied entry. I'm not sure if it is that entry or any entry that merits a response, but I think any entry is a looser requirement and the more sensible one in my opinion. We'll see how it goes. Last log index has spaces in it. What? Why would there be spaces? Well, the communication means that last log indexes are sent out during request votes. Unless it's the same as previous, I don't know. I'm getting hungry, so I'm not sure I want to even sit down and try to distinguish the two. But for now, I will just. I didn't notice this. Sorry, it's a bit distracting. Try to just get to the bottom and get to a source of complete position, even despite the length of this stream. I'm really pushing it, trying to understand what Raft is. Raft, though, you're killing me here, but I am getting there. Last log index is greater than or equal to next index for a follower. Would you do? No. Do we remember what I closed the camera? Did I? No, it's fine. Do we remember what next index means? Why are you not loading? Oh, because I'm clicking on the wrong thing. What is next index? Next index is a leader-only thing that tracks the peers and says index of the next log entry that should be sent. And we also have match index, which is the index of the latest log entry we think the leader thinks the peer has. So it's the next thing to send and the latest entry it thinks it has. Okay. So if last log index is greater than or equal to next index for a follower, a given follower, so it checks it against all the followers. It keeps, without communicating with the followers, it keeps track of what it thinks the followers have for next index, which is the thing that, again, they should be sent. But what is last log index? Last log index is self variable, isn't it? That is it. Commit index. Slightly unclear here. We're not talking about an RPC at all. We're talking about how to initiate an RPC, and this has nothing to do with election. I'm pretty sure. So I think last log index is commit index. Index, I think, is the latest logged one. So this is the important thing. What we're doing is keeping followers updated with data. If commit index, just gonna put a note down in case I got this wrong. Last log index. I think that's commit index, right? Index, I think, is the latest log. Definitely not applied. That's a different process. That's handled by a different piece of code. You know, the general doings that flushing last applied. But this is the point. Is this is explaining what commit index, i.e., last logged, is doing. Well, no, actually, this isn't explaining that. It's explaining. Sorry, it's explaining next index, isn't it? It's explaining whatever changes. But okay, that doesn't matter. Let's not obsess over that. Index, I think, is the latest logged. What the leader thinks is the latest information. It looks at that, the commit index, and hopes that it is further along the next index. Yeah, I don't have less than or equal to custom symbol on this keyboard for now. I didn't install it. The custom keyboard layout I have. Yeah, MSKLC. Guys, check it out. MSKLC is pretty cool. Wow, it's a really old, like redundant piece of not redundant at all, actually, very useful, but old, archaic, kind of updated for Windows Vista last tool that Microsoft made that allows you to program custom keyboard layouts, and it's great. I mean, if you just have a bit of design now, so you can solve every problem you ever had with accents, not being able to type them easily. Like on the other laptop where I have my custom keyboard layout installed, dashes, degree signs, infinity signs, every Serbian letter, every French letter, Spanish letter, things that would have been useful to have in GCSE times if I'd made the layout back then. Still useful occasionally, I have to say, if I'm typing some random word from most of the Western European languages, and you know, a custom array of like dead keys and all the accents, caron, macron, um, grav, acute, circumflex, tilde, and some custom like Danish letters. Um, Icelandic even, yeah, no, it's sick. You can do what you want with a custom keyboard layout. So yeah, I would have been able to type less than or equal to by going Alt-GR equals and then type Shift and the less than key to hit the. So Alt-GR equals is for custom equals. It's a dead key. Dead key meaning you have to then type something else for it to register a keystroke or a character, not a keystroke, a character to add, because the keystroke is just the individual button press that the keyboard registers. Cool. Sorry, my grumbly ranting is a product of hunger, but I really do just want to get to the end of this at least, because then I will know so much. You don't understand. So much learning was done. I'm gonna eat. I'm gonna eat so much. Yep. If you know, this is implicitly for all followers, I think, or maybe no. I should just write for followers. This is Chomsky, so I can just write for followers. I don't need to say for all like I would in maths. If next, for followers, if next index follower, this is kind of functional Pythonic code. For followers, if next index is less than or equal to commit index, last log index. That means that the leader thinks that the follower doesn't know what the latest data is. Because the next index, the leader's commit index, is greater than or equal to the index of the thing that should be sent next. So that thing should be sent in that case because it exists. So what happens? Send append entries to follower with the data, and the state is also a part of it, as in the term. But it doesn't even say that here. It just says send last log index greater to the next index for a follower. Send append entries RPC with log entries starting at next index with log next index onwards. Okay, everything from to the end of the log from next index. That's how it keeps them updated. If successful, update next index and match index for follower. If so, that's an RPC, append entries. If success, update next index and match index implicitly for follower. I think that's implicit. Why are we updating both? Well, because both of them are trying to keep track of how updated the follower is. I'm not sure why we need both. You know, the next entry to send, surely that is the one above the latest log entry the peer has. Both are being updated. What is the difference? We're comparing one. We don't need to compare both, but we're keeping both of them updated. At some point there will be a symmetry break where we do something that implies that there is an actual difference, i.e. we rely on one of them but not the other, because here I guess we could have used match index, not necessarily because I don't know enough about it, but not like for like match index I'm thinking is like one less than next index, because match index is the latest so far and next index is the next one to send, right? So we would assume the next one is the one after the latest one. I don't know. Look at this. If append entries fails because of log inconsistency, okay. If fail log inconsistency, inconsistency in my math speak means not related by extension. Because of log inconsistency, decrement next index and retry. Gets decremented. Retry. So yeah, it keeps decreasing next index. Oh, I guess match index. This is a break in symmetry, isn't it? Match index is what the leader thinks that the follower thinks is its latest entry. Well, it is its latest entry, but it might not be the right one. Whereas next index is a should. It's kind of normative like that, and it's talking about what the leader thinks that the follower should have, which is it needs to reflect what the leader has. And so next index gets unraveled, dragged back up to the point where they agree, and then the updates are sent, and that should cause an overwrite, generally speaking. A few things to think about there. Overwrites being possible is interesting. How else would an inconsistency be resolved? You have to overwrite. But beyond that, also the what was the other thing I just crossed my mind was interesting? Next index getting I forgot. Sorry. Next index getting decremented. Well, okay. At least I said one interesting thing, right? But like, Yeah, if there's a failure because of the log inconsistency, the leader is trying to get everyone synced to itself. It's the leader, everyone follows its leads. Some scuttling in the corridor. Hope that wasn't my doing with my loud voice at midnight. Yeah, I'm going to try to finish this up soon, but I'm so close to the end of the leader doing section, so I will push forward. Yeah, I don't remember what the thing was that just crossed my mind, so I'll ignore it, I think. But yeah, the interesting thing is, the leader, I keep calling it the master, dynamic master, is leader, kind of. Carry on trying to synchronize all the followers to itself by decrementing the should update. Oh yeah, no, the other thing that I said was interesting, I wanted to say is, how do they check for consistency? Does that require checking the entire log? Do we use snapshotting it to be implemented later to say, things are definitely fine here, we no longer need to check this stuff? Because next index gets decremented, it's not an increment only thing. There's no increment assertion, it just got decremented. It's weird, isn't it? It's how is the matching done? That is the question. Maybe match index has another part to play. Okay, let's take a look at the very last line. There exists an n. Hui. What? If there exists a number that is... Oh no, it's a bunch of different terms. Okay, sorry. There exists an n such that n is greater than the commit index. A commit index, I said, is the same as last log index, didn't I? In principle. I think it is. If there exists an n bigger, strictly greater than the commit index, which, by the way, is the index the leader thinks is the latest logged one. Okay? So if there's an n, which is an index n, bigger than commit index, so it's strictly new data unlogged, a majority of match index are beyond n, and the log at n dot term, oh yeah, because they come with terms. But if it's not in commit index, then it shouldn't exist in the log, surely. Well, this is telling us how commit index is updated. It's pretty important. Keep commit index updated. If exists n greater than commit index such that match index greater than or equal to n majority. So we could take the biggest one that has a majority and check if that's also bigger than commit index. But we also need this additional thing. And log n, this is the leader log. But then how can commit index be below the log? Commit index gets updated after the log. Okay. And log n dot term equals current term, according to the leader. Set. Okay, yeah, set is of course just commit index. Set to n. It's a bit weird. I'm starting to lose track of how it all works. The leader stuff is definitely the difficult stuff here. Quite a lot of the general stuff and some of the other, follower stuff and whatever is pretty obvious. But there are bits that I'm not happy with. So, these are obviously absolutely clear. This one is fairly reasonable. This one is ish. And this one I'm struggling with because I don't understand really. Well, I guess this is saying we try to update commit index all the time by doing these checks. But so what am I thinking? Sorry. Yeah, it's only updated in this circumstance, which means that the log n exists conceptually before commit index. Notes it, or before commit index hits n. So it's added to the log before that. Hey, do we remember when? Do we remember when things are added to the log? Is there a section that says anything about when to write a log? This is all about sending append entries and updating the indices, monitoring if things are up to date. Otherwise it does client request still alive leader in it. Oh shit, yeah, no, here it is. Check it out. Client request, immediately append requested entry to log. Okay? That means that, eventually the log should exceed commit index. And the point is, it sets the commit index to reflect the log if the terms match. The term at which it was added reflects the current term, because the current term should not be increasing. Nobody should be calling leadership elections. That is the sign of a failing master. Get it? That makes sense. Current term is stable. Stable if leader is successfully heart beating, which I'm using in a slightly more general sense. It's also sending data is what I mean by that, but you take the point. Heartbeat is all about staying alive. Which is why this checks out, because the leader directly responds to a client by appending its entry to a log during the current term, and the point is it should immediately be able to commit, update the commit index to say, okay, I have kept track of that successfully. The log is up to date, up to commit index, which is how far up to date the log is. Don't forget, that's what commit index is, latest logs. That should be kept up to date, absolutely. In the event that there is new data, but also it has been matched, it has been replicated, distributed to the majority without a new election happening, because current term only increases if somebody called an election. Log n term is the term at the point where the data was received from the client, because that's when we chuck it in the log with the current version of current term. So the point is log n dot term, which I'm going to square bracket as being the term when the client requested, because that's effectively, when I say the term, I do mean current term. If it matches current term, now, which is to say there has not in the meantime been a leadership election. And it also has to be that that has been replicated, which is what this is saying. In that case, commit index can be increased to some extent. The replication, of course, is covered by this section, keeping followers updated. It just continually sends append entries if there are entries to be appended. So this is about keeping followers updated consistently. Commit index is updated to basically register replicated log writes. Keep followers updated is all well and good, but this is the way for the master to know how far it's gotten. Potentially it's the commit index that is saying like, oh, it's not though, because then this would not be a problem. I was going to say it was the commit index that everyone agrees. Everything up to there agrees with it, with every other server. All the logs agree up to commit index. I thought that could be an assertion, but then I realized there could be a log inconsistency. Not necessarily. It is true that send append entries is only called if something is getting out of date. If next index is getting out of date, but the thing is, if the follower itself received shit from someone else, then it could be that there's an inconsistency. And so next index is unraveled and then it is sent up to match commit index. But then when it matches commit index, is the data safe from being overwritten in the future? These are the questions, mate. These are deep, deep questions. That's all I have to say for today. I'm going to rest on that. All these assertions, a decent partial understanding. I'll just let myself sleep on it now. Midnight at 12 in London. And there are some, implementation details about the RPC handling and some extra arguments and things, but I think those are subordinate. When it says this is a summary, it's just not particularly well structured. But I think these are subordinate details that we can forget about for now. And at some point sketch out the implementation, task 2A, heartbeat and leader election. Okay. 3 hours in, I'm about to end. The last thing that I will do very quickly is to just try to run through I haven't even barely looked at this. Learning from the actual paper. It's a thing, not just lecture notes. Read and understand the extended lecture, the Raft paper, particularly figure 2. I'm happy to stick with figure 2. Figure 2 is the one. But yeah, let's just run with the illustration and see what happens. The secret lives of data. Understandable distributed consensus. Hopefully this won't take too long. Single node system as a database server that stores a single value. Client sends a value to the server. How do we come to consensus if we have multiple nodes? Motivating what the point of Raft is. The old distributed consensus. I think it's a very interesting Chomsky problem, to be honest. Raft is a protocol for implementing distributed consensus. Let's look at a high-level overview. Here we go. What do we think the 3 states are? Leader, follower, candidate. Yep. Okay, leader follower candidate. That will be my state variable, I think. All our nodes start in the follower state. Followers don't hear from a leader, then they can become a candidate. Yeah, the timeouts. The timeouts convert the follower to a candidate. The candidate then requests votes from other nodes. Nodes will reply with the vote. Candidate becomes the leader if it gets the votes. If it gets votes from a majority of nodes, including itself, that is the leader election. All changes to the system now go through the leader. Yep, the leader is trying to do everything, but in case it fails, it has lots of backups, and that's why it keeps all the followers synced up. So the leader and the clients maintain the relation. Added as an entry in the node's log, in the leader log, and it's currently uncommitted, so it won't update the node's value. Not clear what that means. What does that? What does this do? Hopefully it doesn't go back. Restart. Each change is added as an entry in the node's log. Maybe just re-explains it. It's quite an interesting tutorial, isn't it? Each change is added as an entry in the node's log, but it's not committed. What did it mean by that? Okay, I think I might skip a step. Sorry. Now go through the leader. Each change is added as an entry in the leader's log. Okay. The log entry is currently uncommitted, so it won't update the node's value. The node has a value? That didn't say that in Raft. The nodes have all the servers have a single value. But it just has a log entry, fine. To commit the entry, it first replicates it. Oh, I think the commitment is the idea of commit index is what monitors what counts as committed in the leader's eyes. I'm hoping no data is lost once it's been committed. That would be weird, but possible, I guess. First, it replicates it by doing the forced synchronization, as we said, the whole unravel and set it up thing. Then it waits until a majority of nodes have written the entry. The entry is now committed on the leader node. It doesn't matter if it doesn't have to wait for all of them because it will keep trying to commit everything at all times. The entry is now committed on the leader node because if it waited for all, obviously, if one breaks, it halts. Whereas the whole point of Raft is it halts, as in pauses, if a majority is unavailable, and that's why waiting for the majority, knowing in advance how many peers you have, how many servers are in the game, all that stuff. The entry is now committed on the leader node, and the node state is 5. Oh, so what? It wrote it did the commit. Yeah, that's so. Commit index moves up to encompass the 5. That's how our implementation is going. The leader then notifies the followers that the entry is committed. Does it? Which of these steps corresponds to that? It registers replicated log writes for itself. It doesn't notify them though that it's done that. It just did the append entries and there's no vote. So this isn't a thing that's reflected in what I wrote at all. I don't think that the entry is committed. It doesn't. This doesn't happen, does it? Not sure. Cluster has now come to a consensus about the system state. Notifies the followers that the entry is committed, but that doesn't mean the followers then commit the entry. That's all. You can't trust anyone in a distributed system like that. You can't rely on the leader being the leader. This is the thing. This is why so much care is being taken out. I'm not convinced this even happens, but nonetheless, yeah, there is a consensus. Because the master has successfully written to everyone else. A few details there that will need ironing out. Process is called log replication, and let's go through a leader election as well. In Raft, there are two timeout settings which control elections. One is the heartbeat, and the other is the something about vote granting. Let me just remind myself. If timeout on receive append entries or grant vote. Okay, so if it hasn't granted the votes in a long time, it makes itself a candidate. I don't know why. Why does that happen? Wait. Did I write that down correctly? In the follower section. All granting votes a candidate converts a candidate. I guess that's like a generic timeout, but it means it converts itself to a candidate even when there's a leader. Maybe that's a good thing. Is it? Let's find out. Let's see if this helps us understand that. First, there is the election timeout. Is the amount of time a follower waits until becoming a candidate. Randomized to be between 150 and 300 milliseconds. So fast. Slowed down epically. The follower becomes a candidate and starts a new election term, votes for itself, and sends out request vote messages to others. The receiving votes node hasn't voted yet in this term. Then it votes for the candidate. Oh, is it per term? Oh, just a thing to check quickly, sorry. This is per term. Sorry, the voted for is in the current term, so I'm just going to emphasize that. Just to be clear, this isn't a cache of previous votes. It's just in that term, did I vote? That means, it goes with the first person to call a vote that thinks it's a new vote, kind of thing. Let's not be too specific. And the node resets its election timeout. Once a candidate has a majority of votes, it becomes leader. Leader begins sending out append entries messages to its followers. These messages are sent in intervals specified by the heartbeat timeout. Followers then respond to each append entries message. The election term will continue until the follower stops receiving heartbeats and becomes a candidate, but... Oh, is it an AND timeout? Or an OR timeout, just to be clear. I've written it as an OR timeout. If the election timeout has elapsed without receiving this or granting vote, so if it has received, this is just a question of English. If it has received an RPC from the current leader, no, I think this is an AND. So both of those things have to have not happened for there to be a proper timeout. Okay, that makes more sense. So no elections are initialized while the leader is communicating with followers. The followers are not going to start to try to overthrow it effectively, unless it stops communicating. It's a very nice system, I have to say. I wish I could apply this to the Pokemon Go Discord. When someone stops communicating, there's an automatic leadership election. Not that there is such a thing as a leader in the Pokemon Go Discord anyway. I should say, I mean, I used to be a mod on that Discord, teach myself a few management skills, and yeah, leadership is an absolute myth. What was I? Sorry, what was I looking at? I was looking at the timeout. Yeah, I think um, I think this is a war. It's just that event, receive, append, entry, or grant vote. If it is receiving, then that will continue to be true, and so there won't be a timeout. No, I've written it correctly. I just confused myself. Sorry. Yep. Term 1, leader is A. Let's stop the leader and watch a re-election happen. You know, they're going to expire because there's no the heartbeat timeout. Yeah, because if it initiated a new term, this thing then voted for it. And it's distributed, yeah, sending RPCs to workers even if they gave up on existing. So A is still in the game, well, RPCs to all servers. Yeah, no, I kind of get it. Node C is now leader of term 2. Yeah, I definitely need to stop. I'm getting lightheaded and hungry. But I understand. I'm just losing the ability to communicate my understanding to everyone else. I'll push myself just a little bit further to get to the end of this shit, and then I am just dropping it until tomorrow. Don't burn out. Don't burn out. Um, yeah. So there was a leadership timeout, and it also timed out because it didn't receive a vote for a long time. So it immediately called an election, and this voted for it because as in C called an election and B was the first to call an election, and because the term is higher, B synchronized terms with C and realized it didn't vote for anyone in that term, so it voted for this one, and then this decided it was leader and started sending requests the data RPCs. Yeah, it's a very elegant system. Requiring a majority of votes guarantees that only one leader can be elected per term. Does it? Um, yeah, because per term, terms are numbered. Per term, all of the servers will only vote for one thing, I think. I think that's why. Let me just check that. It's all about how it votes. Oh yeah, that's written down here in the request vote implementation. It can grant a vote, provided voted for is the thing that it already voted for, or null. So if it's null, the thing that a given voter voted for, any random server in a given term, a given server in a given term, if the thing that it has already voted for in that term is null, then it auto votes for the thing, provided there is some benchmark of it being up to date. Or if it has already voted for the exact same one. So it can vote for at most one. Because voted for, yeah, okay, so the deduction I've made here, which I will go ahead and spell out at the bottom as well, just because voter votes for one server per term, caches it in voted for. Auto votes if null, provided it passes some other conditions, and if it's not null, it absolutely has to be the thing that it already voted for. So it will only vote for one thing, and therefore, because every vote casts only one vote, if there is a majority vote, that means there aren't enough votes in that term by pigeonhole. Wow, counting combinatorics. Nah, just generally, there aren't enough votes for anything else to get elected as leader, and therefore there's only one leader. Understood. God, the lightheadedness. Just come on, push through to the end. Two nodes become candidates at the same time. Then a split vote can occur. That's the annoying thing that you're trying to desynchronize when they call votes. Here's an example. So which two are going to hit the votes timeout? A and D? Two nodes both start an election for the same term. And each reaches a single follower node before the other. I love the geometrical way that it's described that. Oh shit. I double tapped. Do you know what? I'm restarting the whole thing. I mean, this isn't a problem because I'm just gonna mash the continue button. Won't take more than a minute, come on. Because the fucking back button just disappeared, yeah, because it's a work in progress or whatever. Mash. The button mashing is real. You know, we're doing leader election. Yeah, now we have to wait for these timeouts. Sorry about that, guys. I mean, other than this UI problem, I think this is a good guide. I'm enjoying it. I'm happy to try to push through. Come on. Split votes, please. Eyes are properly glazing now. Okay, here we go. That took over a minute. I'm not going to do it again. Just be careful not to click too fast. So the exact position where we were, election at the same time, and each, oh god, they fucking randomized the order of the animation. Each reaches a single follower node before the other. Now each candidate has 2 votes and can receive no more for this term, because those are the votes, the unique votes were assigned. You know, voted for B, voted for D, node B, node D, which they both, of course, voted for themselves. Term 4 vote count. The nodes will wait for a new election and try again. Your hung parliament. Something else will hopefully have called an election, and now it is leader. Amazing system, seriously, I love it. Log replication. Once we have a leader elected, we need to replicate all changes to our system to all nodes, done by using the same append entries message that was used for heartbeats. Let's walk through the process. First, the client sends a change to the leader. I think the red thing is a heartbeat. Change is appended to the leader's log. Then the change is sent to the followers on the next heartbeat, so it's calling heartbeats and append entry the same thing, okay? Because it's a periodic thing, it makes sense to do that. An entry is committed once a majority of followers acknowledge it. You know, reply yes, and update the match thing, the match index, I guess. And the response is sent to the client. Now let's send the command to increment the value by 2. Our system value is now updated to 7. It's only the master that has the system value. These are updated to 7 as well, but... Oh no, sorry. I am wrong. Every single server has a general state variable of its own commit index. What it thinks is the last applied. All of them flush data, but this is saying that only the master is incrementing commit index, which is not necessarily true. This. Yeah, but it has to use match index, which is a master only thing. You know, knowledge about all the other work of all, sorry, master and leader, knowledge of all the followers. So how can commit index even be incremented otherwise? You know, nothing else is incrementing commit index. Well, you say that. Look at this. There's some information here about how append entries works. So there's some information that's not covered here that we'll have to. Okay, there is a bit of extra stuff then that I don't understand yet. Just the layout is just not great, but never mind. Sort of understand. Raft can even stay consistent in the face of network partitions. Set a partition. Just watch the elections happen. Vote count 2. How did this get? Because of our position, we now have 2 leaders in different teams. This is heart beating, so it didn't get elected. But this is the minority network. You know, the reason this got elected is because it got 3 votes at some point. Let's add another client and try to update both leaders. Deary me. One client will try to set the value to 3. Node B cannot replicate to a majority, so its log entry stays uncommitted. It has to know how many are in the entire network in order for the whole majority system to work, right? So the entry remains uncommitted, even though it is in the log, and that's how you get an inconsistent log, but it's not committed. Other ones try to set it to 8, but because it has a majority, that succeeds. Replicates to a majority. Now let's heal the network partition. Node B will see the higher election term and step down. Yeah, because Node B was not able to be re-elected. It could not get a majority vote after the network partition. So this is the whole term sync we were talking about. And A and B will roll back their uncommitted entries and match the new leader's log. Now they're all perfectly synced. Our log is now consistent across our cluster. I wonder if this has any downsides. The end. Well, this claims it doesn't. For more information, we have the paper and there's a website. It's designed to be easy to understand and equivalent into Paxos, the old school one, in fault tolerance and performance. Relatively independent sub-problems, and it cleanly addresses all major pieces needed for practical systems. Available to a wider audience like me, your common or garden mathno. Develop a variety of higher quality consensus-based systems than are available today. I might even start reading some stuff, but I'm perfectly happy with that. Even though I don't fully understand it, I've definitely got the gist easily. Even just running through that guide as an entry point, because I ran through paper 2 as an entry point. Paper 2, the famous, sorry, figure 2. Figure 2, the famous specification. I haven't even done all of it yet because it's very detailed, but the guide to Raft is also a very nice way of getting into it, figuring out what it is. Well, I will end on a slightly disorganized note and just say, okay, what happened today. It's good. I think I'm progressing. I'm going to sleep on what I've learned, and I'm going to, rather than trying to summarize what happened today, I'm just going to pull myself together and come back tomorrow um, with, a way forward and a look at everything that happened. So with that in mind, I am just going to close everything down and go to sleep without too much additional commentary. But we'll see. It's a lot of shit that I've written here. We'll see. There should be a MISC section. Oh yeah, sorry. We will see if I've made sense to myself, if I've actually learned anything. This is it's interesting. This really is the interface. Like I said, nothing I've written here comes into Raft itself. It just comes into the connection between Raft and the actual state machine. What the tester, what is expected. So I have correctly titled that the interface. Yep. Okay. No need to improve that. Okay, guys, I'm, oh my god, exhausted, but happily exhausted. I have done so much. I will do a session tomorrow, like I said I would, but I might try to cut it down because this one is almost a double session. It's an extremely long one. 3 hours since my last ping here because I just don't know how to split it up. Time spent purely trying to understand how Raft works. No, there has been sketching, but it's been along the way and just mostly just trying to get it. So I will think about it. I might even sleep on how to split up the stream. So yeah, there might not be a stream split published immediately, but I will catch everything up tomorrow. And yeah, I forgot to sort the GitHub as well. I'll have to do that tomorrow after session 3. Yep, on that note, session 3 we'll pick it up. We'll see what the hell just happened. I don't know what, when you learn so much stuff in such a short time. Confusion, man. Confusion. Pure confusion. So, 82 dropped frames. Could be a whole second. A whole second disappeared at some point. And a bit. Yep, so with that, nothing else to say. Tomorrow I'm picking up the pieces and trying to figure out where the hell I am. After all, I just inserted so much information in my head, man. Mind blown. Gotta eat. Gotta sleep. Like, God, I was gonna play a video game or something. I don't know if I can. Exhausted. I've never really driven myself to this position during MapReduce, but that's because MapReduce is easy in comparison to this. Seriously, easy. And this is some cutting edge shit as well. 3 years old this project is, and understandable version of Paxos. I mean, sick. It is understandable. I've basically understood almost all of it. Well, understood is a strong word, but process most of the information. That's it. That's all I have to say. Back next session, 12 p.m. today. I guess it is today. It's now 12 a.m. 00:44. Saturday, 12 p.m. To 2 p.m. 12 p.m. to 2 p.m. straight off the back of some sleep. Process all the information, pick it up where we left off, and then I will take a break for maybe even a day and a half, just to, yeah, try driving through. Next session 3, 12 p.m. to 2 p.m. on Saturday, i.e. today, in 11 hours and 15 minutes, where we continue with Paxos picking up all the pieces and Raft, picking up all the pieces, recovering, and knowing what's happening next. God, my brain is fuddled. My brain is fuddled, man. And I'm out.